Okay, the first question has part A and part B. It was basically if you have a function y and it's 2ex plus 3e2x, does this function satisfy y squared negative 3y, sorry, y prime negative 3y prime 2y equals 0? So basically, if you, instead of y, if you put this, and then if you take the derivative and you put it here, and you take the second derivative and you put it here, would that actually go to 0? Well, let's see. So first, we need to take the derivative. You know the derivative of 2ex is 2ex. The derivative of this would be e2x times 2, and there is 3 becomes 6. To take second derivative, this one is itself. This one would be e to the 2x times 2, and this one is 6 becomes 12. Now, let's consider this the left-hand side, and this the right-hand side. Now, does the left-hand side equal right-hand side? Now, check left-hand side. You need the second derivative, which is 2ex 12e2x minus 3 of the first derivative, which is 2ex 6e2x plus 2 of the actual function, 2ex 3e2x. Now let's see. This one has nothing in front of it, so we can just say it's 2ex 12e2x. We take the negative 3 inside, so it becomes negative 6ex negative 18e2x. We take the 2 inside, becomes 4ex and 6e2x. Now, does this actually equal 0? Now, let's check the ones where the exponent is x. You have this one, you have this one, and you have this one. And what? 2 minus 6 is minus 4, plus 4, 0. So these are gone. Let's look at the ones where exponent is e2x. This one, and this one. 12 minus 18 is minus 6, plus 6, that's gone. So the answer is in fact 0. Good? So, that's the first question. Question 1b. You're given y minus ln y equals x squared plus 1. And the question is the derivative of this, if you do it implicitly, is the derivative of this 2xy, y minus 1? Now to do the derivative for this, the derivative, if you remember implicit differentiation, the derivative of y is 1, but since it's y, we put y prime. The derivative of ln anything, the inside of the line goes in the bottom. The top would be the derivative of the bottom, which is 1, but since it's y, we give it a y prime. Derivative of x squared is 2x, and the derivative of 1 is 0. You don't really have to show the 1, doesn't really matter. And then if we take y prime as a common factor, from the first one, you have 1 left. From the second one, you have 1 over y. And that's equal to x. Well, to isolate the y prime by itself, you take the 2x over this. Now, are these two equal? Not yet, because in math, we don't like seeing what's called double fraction, a fraction inside of another fraction. So we need to simplify this. And the way we simplify it is you can times by y over y. Because y over y is eventually 1. So you're multiplying by 1. You're not changing anything. But this y would cancel the y in the bottom. Now watch. Y times 2x would be 2xy. Y times 1 is y, and y times 1 over y, the y's cancel, you get negative 1. Now we see this, that's the derivative. Now, it's easier to use y prime throughout the process, easier to look at, but when you get to the final answer, y prime is in fact dy over dx. So instead of y prime, you can just say then dy over dx is 2xy, y minus 1. Good? That's the first question. It wasn't bad. So we go to question number 2. Question number 2 is, this is really the start of differential equations. You have dx, dy, dx, e negative y, x plus 1, and they tell you y at 0 equals 2. And they want you to solve for this. When they say solve, they mean they want to see it as y equaling something. So you gotta put it so that it's y equaling something. I'll go over this slowly so you get the idea. It's not that bad. You need dx and dy to be on either side on top. So you need dy and dx both of them, one is on one side and the other on the other side, and they gotta be on the top. You can't have them in the bottom. And also, the y's must be with dy, and x's must be with dx. So, to make life easy, the first step is you do the cross multiplication if you have to. So I'm going to go over and do the cross multiplication. So I have x dy e negative y x plus 1 and dx. So now I have c dy and dx, both of them on top. But I got to have the x with the dx and the y with the dy. So I'm going to divide this and divide this. So you go, I'm going to bring this and divide it here. And same for this one, bring the x and the bottom to divide. So I have the dy dx on top. I have the x's together with the dx. And I have the y's with the dy's. Before you do anything else, I mean, you have the solution now. Before you do anything, see if you can simplify this more. E to the negative y, I can bring it up and becomes e to the positive y. Here, since I have one term in the bottom, I can do what's called the distribution. So I can go x over x, that's 1, and 1 plus 1 over x. So x over x is 1, and 1 over x, and all of this dx. So after you simplify, you can integrate both sides of the equation. You know, this is dy. You know the integral of ey is ey. The integral of 1 is x. And the integral of 1 over x is ln x plus c. Now, you always put the plus c with the x part. Now, they give you this initial condition to help you figure out what the number c is. The way we read this is when x is 0, y equals 2. So here, replace the x by 0. I think the initial condition, if I'm not mistaken, it was 2 inside and the 0 outside. So when x is 2, y is 0. So let's see here. Y is 0. So e to the 0, you put x here, so 2 here, 2 plus ln 2 plus c. E to the 0 is 1. You bring this over, so minus 2 minus ln 2 equals c. 1 minus 2 is minus 1 minus ln 2 equals c. Now I know what the value of c is. So I can write this one here as, therefore, ey equals x ln x minus 1 minus ln 2. But remember what I said, the concept here, the goal of this is to be able to write it as y equals something. So we got to the point that it's this way. We need to find y. So to get rid of this y here, I'm going to ln both sides of the equation. So I'm going to ln the e and ln all of this. Anytime you ln, it's pretty much better to put the inside in absolute value. Same for this. Why we're learning? Because, you know, ln e cancels out, so I know y equals ln absolute value x plus ln absolute value x minus 1 minus ln 2. So I was able to get it in this form. Good? This is the second equation, the second question of your recitation. So we do one more, which is question number 3. They want the general solution for y dy x dx cosine x. When they say find the general solution, they don't give you an initial condition where, like last time, y at 2 equals 0. So leave the constant. So don't do anything for the constant. So again, when we solve, you gotta have the x, the dx and the dy on the top, x's with x's, y with y. So we start with cross multiplication. Y dy x cosine x dx. So we have the dy and the dx on top and the x's together, so we're good. Now, in order to do this, we need to integrate both sides of the equation. This one is easy, this one is y squared over 2. The integral of this, if you remember from Cal 2, it's done by parts. So we used to go and say this would equal I. And then you let u be x and dv cosine x dx. You find the derivative for this and you integrate this. And you know the integral of cosine is sine. The by parts rule is I equals u times v integration of v du. So I equals u times v would be x times sine x. Minus v du would be sine x dx. So you have x sine x. The integration of sine x is negative cosine, and you have a negative becomes plus cosine. So integration of sine is negative cosine. With the negative becomes positive cosine. That's your I. So now I know the result of the integration. So the integration here is x sine x plus cosine x. Plus a constant. And I told you last time, the constant we always put with the x part. Now, in order to get rid of the 2, we multiply both sides of the equation by 2, so you have y squared times 2 would be 2x sine x plus 2 cosine x plus 2c. Now, since you know c is a constant, a number, 2c is also a number. So we can call 2c k. You don't have to leave it as 2c. You can just call it k. So now y squared equals 2x sine x, 2 cosine x plus k. And to find the y, because remember, the entire idea here, the concept, is to find y. And obviously, to find y, we're going to square root this, but remember, it's positive, negative, the square root of this. This is the general equation for this question. Now, for the idea of, this is the first workshop, so that's probably, it's short, not a lot of questions. But I want to do one more question, not part of the workshop, but I know that Diego, special Diego, loves this idea. So I'm going to do one more question, but in terms of the assignment or the workshop, we're done. And you probably, if he assigned like suggested questions to look at, you probably see something similar to what I'm going to do now. So, you have, say, dx or x dx, and here we'll have y squared plus 1, put dy here, and x squared plus 2x dx. Or we can just put the dx here. And you know, again, the concept of this, I'm going to just say find the general solution. So I'm not going to give you an initial condition. You know, the idea of this is to put the dx and the dy on top, x with dx, y with dy. So we start with the cross multiplication. So now we have the dx and the dy on top. I'll move this to the bottom of the dy. I'll move the x to the bottom of dx. So I have dy y squared plus 1. And here I have x squared 2x dx, and I'm moving the x in the bottom. Then you always look at this and you ask yourself, could this be simplified anymore? Yeah, well, we can write this instead of dy, I can say it's 1 over y squared plus 1 dy. So the 1 here, I can separate it. And again, usually, always, when you have one term in the bottom, you can do the distribution. So x squared over x is x, and 2x over x is 2. Now, when you get to this point, the idea here is to see if you can integrate both sides. So you integrate both sides of the equation. So the integral of both sides of the equation you need to be familiar with the integration rules. So I gave you the one with the derivative, you probably still have it, but the integral of this is tan inverse. So we say it's tan inverse of y. And the integral of this is x squared over 2x plus c. So we got to this point, but remember, the idea of finding a solution is to see if you can isolate the y, have y by itself. To do this, to cancel this tan inverse, I'm gonna tan both sides of the equation. So I'm gonna tan the tan inverse of y. I'm gonna tan the x squared over 2x plus c. Because tan and tan inverse, they cancel each other, so you have y left. And here is tan x squared over 2x plus c. This here is what's called the general solution. So one way, like in this question, you learn how to get to isolate the y when it's ln, when it's e, when it's something inverse. One more concept of ideas that they like and might ask you to do it. You might see something like x dx and dy root y. So they can start the problem by putting the root y here and tell you to find the general solution. But you know, finding the general solution would always be dy and dx on top, the y's with the y's and the dx's with the dx's. So currently we have the dx and the dy on top, but the root y or the y is not with the y. X is fine, so just leave it. The root y you bring down. And you know, root y would be y to the exponent half. Okay, you can bring it up. It would be y to the minus half dy. So once you get it to this point, you can integrate both sides of the equation. So you can integrate this, you can integrate this. The integral of this is x squared over 2 plus a constant, and I told you again and again, the constant should always go with the x. To integrate this, you know, you add 1 to the exponent, becomes half, and you multiply by the reciprocal. So you add 1 to the exponent, becomes half, multiplied by the reciprocal. So at this point, we have, I'll start with this, 2y to the half equals x squared over 2 plus c, which is 2 root y equals x squared over 2 plus c. We need to isolate the y, so we can just say take this times half. That will leave the root y by itself. This becomes x squared over 4, and this becomes c over 2. We can say c over 2 call it k. So root y equals x squared over 4 and k. So now to find y, you basically square this. So 2x over 4 plus k squared. I don't think that they could, or the way that he could play with this. Now, you see the answer, so have a good look at it. I'm going to change one thing. What if he tells you this cubic root? So instead of square root, it's cubic root. So cubic root, so again, you move it in the bottom, and you know cubic root means to the exponent third. And you move it up, it becomes to the negative third. So the integral of the left-hand side is the same, no problem. Now you integrate y to the negative third. You add 1 to the exponent, and I told you again and again, when you add 1 to the exponent, negative 1 over 3, you add 1 to it, becomes 2 over 3 times the reciprocal. So now, we have x squared over 2 plus c, 3 over 2, and y 2/3. To get rid of the 2 over 3, I'm going to multiply this whole thing by 2/3. You multiply this by 2/3, the 2 cancels with the 2, you have x squared over 3. This becomes 2c over 3. Here the number is gone, and you have 2 over 3. So you cancel the number. Now again, this, you can call it k. You have x squared over 3 plus k, and this. Now, in order to do this, or in order to understand how we can get rid of this, when you have an exponent like this as a fraction, and listen carefully, get rid of the bottom one first. So I'm going to get rid of the 3. To get rid of the 3, I'm going to cube both sides. So it becomes x squared over 3 plus k cubed, and that leaves me with y squared. So to get rid, when you have a fraction, exponent always gets rid of the bottom number first. And if it's 3, cube. If it's 4 to the power 4. If it's 5 to the power 5. Now, to isolate the y, you say y would be positive, negative, the square root of this. And obviously, only when it's an even exponent, you need to do the plus minus. So if this was 4, you'd be plus minus the 4th root of this. If this was 6, plus minus the 6th root of this. But if this was cubed, it would be just the cube root. So you do the plus minus when you have an even exponent. This is a very good introduction to the beginning. I know, and you know, that probably things will become a little bit more complicated later on, but we'll go one step at a time. I think I do have some material for Diego. I think I have a midterm, or we can use that. And also, Diego is known that if you do the workshops, you're fine. So we're gonna do all the workshops, and if I think that there is a room to add some ideas like today, I'll probably add some ideas later on. Okay, my friend. Good luck.